Welcome our next speaker, Kreuzer. He comes from outside our little community and he's bringing in some ideas about
Actually in the IoT space a while ago, heavily in Eclipse IoT. A few of you might remember me from those times. By now I'm working within Deutsche Telekom in the AI Competence Center, developing applications and products that are Gen AI based internally. And from those developments that we do internally, we actually build a platform that we call Elmos, and which we open sourced beginning of this year. So it's a very fresh incubation project at Eclipse. And yeah, so I will show you how that can be used and what it's all about. But let's first look a little bit back. So that we're doing software development for all of us doing things not in car, but rather as applications within our companies. We are now more or less having learned over the past decade how to build robust, scalable cloud applications, and a few patterns have emerged from there. We're not building monoliths anymore, but we try to split things up into microservices, or having different teams working on different parts and making it easy to assemble those things. We package everything into containers to make it easy to shift them around, to deploy them here and there, and also to enable us to easily replicate, copy them in order to scale our applications if the traffic increases, that we can have multiple instances handling all the traffic and work. So this is more or less how we are nowadays used to build applications in the cloud, and yeah, what works pretty well. Now, unfortunately or fortunately, we'll have to see, there is a thing coming our way which is called generative AI. And this guy, Andre Karpathy, I'm not sure how many of you know him. I think he's one of the greatest minds in the AI space. He used to be the director for the autopilot system at Tesla in the early days. He was one of the founding members of OpenAI at the very beginning when it was all meant to be non-for-profit. And he does really cool YouTube videos explaining how an LLM works internally that even my mother would understand it. So I can really recommend that. He's a great guy. And this tweet here from him, it's from 2017. That's 7.5 years ago. And he claimed at that time gradient descent, that is the mathematical method to actually train neural networks, can write code better than you. And we just seem to now see that he seems to have a point there with Copilot and stuff like that. So the AI chatbots are really doing a great job already in writing code. And so yeah, he more or less already said 7.5 years ago that yeah, something might be changing there, the way how we implement software. What he also coined is the term software 2.0, meaning that the classical software development is software 1.0. We write the code and we compile it, deploy it, and everything fine. Software 2.0 now doesn't mean for him that actually it's an AI that writes the code that we compile and deploy, but rather that our application does not consist out of written code and algorithms, but it's actually based on neural networks doing the job and the heavy lifting in the application itself. And that's really a completely new paradigm on how we look at software and what that means for software. And just to show you some analogy. So on a classical operating system, you have the central processing unit as the core part that does all the processing for you in a very deterministic way. You give it some RAM, some persistent memory, some peripherals, and an operating system more or less assembles all that stuff, builds a platform on which developers can now develop applications and run that on that operating system. So that's the classical view. With the Elmos project that we've started, we said, well, let's try to shift that into now the generative AI world, where we consider large language models as our core processing unit, which does more or less all the magic, which does the heavy lifting for your applications, and which you can use as a fundamental core part of that. You give it some short-term memory, long-term memory, some tools next to it, and you can build then a kind of platform operating system on top of that, on which, again, the developers can build applications, with the only difference that this time they are typically called AI agents instead of applications. And clearly, this Elmos language model operating system is not a replacement for your Linux or Windows that you install on a PC. So it's not running directly on a piece of hardware, but it runs on a piece of infrastructure that provides those things. And in enterprise deployment terms, that's typically, for example, a Kubernetes cluster, where you say you're running your applications, and that's the infrastructure on which then Elmos builds upon. Which means in an enterprise deployment, what we did with Elmos is to say, well, okay, we have Kubernetes as a foundation here. We use Istio as tooling that enables us to have our in-cluster transport encryption, for example, and also things like traffic management. So we can, for example, do canary deployments, so have a new version of an agent, deploy it and run it only on 5% of our traffic to do some early testings, and all the nice things that all cloud application developers know and love and have skills in to run their applications. And that's one of our main drivers to actually say, well, we want to enable existing development teams that are performant, that have their skills, to enable them and use LLMs and Gen AI technology within their applications. We don't want that enterprises have to say, well, we actually need completely new teams. They have to be only data scientists running Python scripts and forget about all the rest that we've ever built and learned and do something now completely new just because Gen AI is around the corner. So we really believe in enabling the existing teams to build applications in a different way, but with all the tools and skills that they have. You see then that the agents here, there can be various agents then running on that. Elmos makes them a first-class citizen on Kubernetes, so that they have their own life cycle. You can deploy them, or you can easily query them on their details. And this orange part here, Arc, is one way that we provide in Elmos to very easily create those agents, but you can deploy any kind of other payloads here as agents using LangChain, Llama Index, whatever framework you like, and integrate that as well in a multi-agent system. Now, just a brief look at an agent. I said it's very similar to a classical application as well. So it has access to memory, long-term, short-term. It can trigger some kinds of actions, so do some stuff, typically through tools that you make available to them. But the big difference to a classical application is actually the part on the right side here. So in a typical application, you get the input, you have your algorithm programmed out, and it's processing the input to do some actions and produce the output. For AI agents now, there is this so-called planning phase. So it gets an input, it doesn't have any algorithm how to process it, but it more or less tries to reason itself, okay, that's now the task I have to do. How do I best deal with that, and how do I get it executed? And so it does a planning phase, it figures out how to do it, and I would call that a kind of ad hoc algorithm generation, more or less, at runtime, to say, okay, I'm now laying out these steps that I would like to follow to address the task and then do it. So that's really a very different way to other applications. Besides tools, agents could potentially also reach out to other agents. If they find that there are agents with certain skills and capabilities, they can make use of them to also fulfill their own task. And that's why we're talking about a multi-agent system. And part of Elmos is the so-called Elmos protocol, where we enable agents to discover each other, to negotiate how to communicate with each other, and so to be very dynamic in their whole capabilities. And if you spin that further, we're saying that, well, for an enterprise deployment, you would do that in a Kubernetes cluster, but the Elmos protocol itself is not specific about Kubernetes, but we're saying you can scale it up to the scale of the whole internet, talking about more or less the internet of agents in the end, to have more or less agents all around. You could think you're coming to your car, in your car is an agent deployed. Your smartphone can discover it automatically, can figure out what to do, and communicate with it in a natural way through natural language without needing any interface specifications, without needing any kind of standards and whatever else. That's the whole magic about using natural language for providing tasks to things. I bet that sounds really scary to anybody doing embedded development for cars and safety and so on. But it's a world that we will be confronted with and that we have to prepare ourselves for. Now, on the Eclipse LMOS protocol, we're also in many discussions with other groups like W3C and so on, and we're also looking very closely there on the Web of Things, for example, which does similar things for the IoT space. And so we're really hoping that we can address or position Elmos here to be part of the open web to enable sovereignty of our companies on where to deploy things, not to have everything just running in big companies' data centers, but that you can run stuff on-prem, that you can have your own systems and make that available. Now, that's a long-term vision, more or less, flying high. Let's come back to Earth. And what you need very first is you need some agents, of course. I mentioned this Arc framework within Elmos. It's a Kotlin DSL, a domain-specific language, where you see an example here on the right side, which is also fairly simple text description of what your agent is supposed to do and how it should actually answer any kind of requests it gets. The cool thing about this Kotlin DSL is that you can start that easily, just writing down a few lines, and you can even pass that task over to product managers or whomever else. It doesn't have to be developers. To do early prototypes, early demos and POCs, but you can then evolve that and use the full power of the Java ecosystem of the Kotlin programming language to make that a multi-tenant, scalable application that you run as a production load in the end. So that's the idea about Arc, making it simple to start with that and not throwing it away and then go with something else to production, but really use that as the starting point. And now comes the very daring part of me, because I'm trying to do a live demo for you guys now using Gen AI, which is completely indeterministic and I can't guarantee for anything. But let's see how that works out. That's also a result, yeah, that you just close your eyes and forget about the stuff then for the future, I know. Okay, so I've prepared here some Docker containers that you might actually know. It's from your blueprint of SDV, the fleet management stuff. That was the best blueprint I could find to say, okay, that's somehow usable to do a nice demo. I set up multiple containers here to have not just one vehicle for fleet management. One didn't seem enough. So I set up at least 3 here. Let's have a look at Grafana that should be running here. Yes. So all here local on my machine from your blueprint. I can see the fleet dashboard, and I now have 3 different cars here. Wonderful, that seems to work. Yeah, so it's driving somewhere here in Frankfurt, this one. We have another one in some other city. and a third one driving around, yeah, with different values. Okay, so everybody who knows the blueprint should recognize that roughly. So 3 cars with some demo data running here, pushing all their data into one single influx DB in the backend. Now, I have a small project here. It's using the Arc framework. It's actually a small Spring Boot skeleton around it. And I've prepared now here one DSL, one description of an agent, giving it a name, the fleet management agent, a helpful assistant that can provide information about your managed fleet. Using GPT-4o as a model, providing some tools, we'll see that later. The goal is you're a helpful assistant that can answer questions from the fleet manager, be helpful and professional, answer concise and short, only answer what has been explicitly asked for, use the knowledge section in which we then see the user would like to know about their fleet of vehicles like speed, curb right driving, pausing, fuel, etc. Retrieve the latest telemetry data through the API and provide the answer. So that's more or less all my coding for this assistant. And with the tools, I have created another script, a small Kotlin script, which now says, okay, I'm actually providing one function to that agent because there, I told him there's an API for telemetry data. So this is what I need to make available to it. The function is simply called get telemetry data, returns telemetry data of the vehicles. It takes a single parameter, which is called query, and which is a string parameter. And again, I'm just describing this parameter now by prosa text here. So I say this parameter is an InfluxDB version 2 query. For example, it looks like that, just to give it an idea of it. Make sure to use range before filter and group operations. If asked for the current value, set the range to a small value so that it's not querying too much data. And then I looked into the InfluxDB and just gave it now here the list of available fields like start, stop, time, value, field, measurement, trigger, VIN, and the underscore field values, total engine hours, blah, blah, blah. So the stuff that can be found within the Influx database. But I don't have to give any kind of schemas, descriptions, and ways how to access it here. So just plain prosa text. Now, if a query comes in, I'm constructing an HTTP body, simply saying from this demo bucket, do that query. I'm sending that to localhost, so to my InfluxDB with authorization, posting it, getting a response back. And if the response is a 200, I'm happy and I'm returning the body of the response simply to the agent. Otherwise, I'm throwing an exception, which hopefully won't happen. Okay, so that's all the code, fairly easy, fairly straightforward. And let's see what we can do with that. So I'm starting this agent here. As I said, a small Spring Boot application. Resolving dependencies. Shouldn't take long. Come on. Getting there. I'm on the internet through my hotspot, so possibly the dependency resolution took that long because of that. Okay, but we're here. This is our data. Now we have a small tool called Arc View, which is a developer UI now just for Arc to communicate with our agent through a chat interface. Oops, sorry. So we can see here it's connected to localhost. That's where our agent was spun up. And we can now... That's where the Spring Boot application is listening now? Exactly. That's the Spring Boot application at port 8080. And so I can now directly send local query to it, like, what am I going to ask? Let me check here. Is any of my vehicles low on fuel? And we see here that's also for debugging reasons, so it creates a system prompt, sending the information that we provided more or less as a description. And we see that it calls our tool, the get telemetry data. And on here, we see there is a query, and it queries for fuel level 1. So it figured out the right thing from actually the list that I provided it. Got a lot of data back here, and it provided me an answer. One of my vehicles with VIN 250 at the end is low on fuel with approximately 10.1. Let's have a look. It's not this one. Indeed. And the 250, that looks low on fuel. Yeah. Okay, so it figured that out and answered it. Another case is, should I prepare myself for AdBlue refueling? Always. No, not beer refuel, Kai. Yes, in some way. So yes, I should prepare for that. 532, it says. Let's check that as well quickly. Yep, that one is pretty low on AdBlue. And the cool thing for me here is as well that it figured out that actually AdBlue is the field catalyst fuel level. To me, I'm not speaking that perfect English, so I didn't know that catalyst fuel is actually the AdBlue stuff in a vehicle. But the LLM knew, it figured out, okay, what is my question probably meaning, and got the right values out of that to answer that. Another cool thing is I can ask in which cities are my trucks located. Let's see if that's working. Yep. So the first one in Prague, the second in Frankfurt, the third in Munich. And if we look at the maps, that's actually also matching. I didn't provide it any kind of lookup service and whatever. So all it did was to look at longitude and latitude values and then figured out itself, okay, which city might that be where it's located right now. And likewise, you can also ask what's the biggest between two vehicles. So you can let it do some calculations here. Okay, and that's now the demo effect, so that's not what it's supposed to answer here. Okay, the biggest distance, exactly, yeah. So it actually answered, it answered what I asked for, yes. You're absolutely right, Kai. Biggest distance. It depends on the drivers. It would have to learn a little bit. Yeah. Okay, so here now, as says, biggest distance between Prague and Munich, roughly 300 kilometers. Sounds roughly okay. uh, how long does it take for those two to meet in the middle? Let's see what it answers. Assuming both travel at an average speed of 80, total distance is 1 hour 52.
Okay, I would say
okay.
that's it, guys.
So
that is pretty amazing.
Yeah,
so
I'm
what to do on the weekend.
I'm stopping the demo before anything goes completely wrong, because so far it did pretty well on my questions. But yeah, that's really what I wanted to show. It's really, you give up some control by saying, well, you're not coding stuff anymore, and you have everything deterministic, but you're gaining a lot of freedom in not having to actually define your use cases up front. You can ask any kind of stuff, and it will try to figure out the best way to really provide you an answer with the possibilities it has at hand. And that's really cool. And you can think of very different kinds of applications that you can build with that in the future. And I think, it's quite fascinating and cool stuff to come. And with that, I'm actually also at the end of my presentation. And thank you for listening.
That is pretty awesome. So we have time for one question. Just one. One.
Right. I want to be maybe a little bit pessimistic and ask, because it's a super nice demo. Like it looks really fun. There's a lot of really nice demos for large language models building like proof of concepts and all these things. Do you have any evidence that this can be used to build anything for production? Because
excellent question, because as you say, Eclipse incubation project that started beginning of this year that can't be taken serious, and you better wait for 5 years. The cool thing is that we open sourced that after we implemented it and use it already last year in production since last year. So actually this Elmos project is powering the Frag Magenta chatbot of Deutsche Telekom website, as well as the customer service hotline. So if you're asking questions on the website around your contract, about your last bill, why is it now higher than the 2 months before? This is all answered by agents that we've built and run on Elmos in production.
Okay, so it's the same system but instead of producing code, it answers questions with some context, but you didn't build that system like that, right? Or did you? Did you build the full chatbot, like with all the authentication and all the like necessary steps, I guess?
Well, as I said, the DSL in which you implement those things, you still do classical coding, as I've showed here. Yeah, so this is still code that you write, and this is also what you would do. Like, okay, there's an user coming in. He asks about his bill, then, okay, he needs to authenticate, and the LLM decides, yes, okay, for this question, the user should authenticate. So it calls a tool, which we would then have implemented. Okay, this is now how to authenticate that user. And so yes, in some way, everything is really built in those agents, and the logic is running that way, indeed. That's and really cool. Of course, it's tricky to make it all stable and production ready, but it works.
That is pretty amazing. I also want to know why I spend so much money of my electric bill running events. So thank you so much, Kai, and maybe you guys can reach out to the Elmos project.